In this unit, we're going to explore situations involving ratios and equivalent ratios. We're also going to identify different ways to represent ratios. As we work together on the activities in this unit, you'll add to the things that you already know about ratios. You will need these materials today. If you have a whiteboard and a marker, that's great. If you don't, that's okay too. You can use a notebook and a pen. Take 45 seconds to go get your materials. We'll start by considering what we mean by the term equivalent. So to demonstrate what I mean, I'm going to make a couple drinks because I'm actually feeling kind of thirsty. So what I have here are 2 glasses of water. These glasses have equal amounts of liquid. So in this glass, I have 1 teaspoon of drink mix. And in this glass, I have 4 teaspoons of drink mix. If I took a sip of each glass right now, would they taste the same? No way, because I didn't use an equal amount of mix for each drink. Since we are working with recipes today, let's first remember what it means to change a recipe to make different amounts of food. Let's say you're planning to make cookies using your favorite recipe and you're going to double the recipe. What does it mean to double a recipe? Well, if we double a recipe, we double the amount of every ingredient in the recipe. So for example, if my cookies call for 3 eggs, I'm gonna double that and make sure I add 6 eggs. And when I'm done, I'm gonna actually end up with twice as many cookies as I would with a single batch. It's really important when we scale a recipe either up or down that we make sure that the cookies taste exactly the same as if I was making that single batch. Let's give it a try. A recipe for 1 batch of cookies calls for 5 cups of flour and 2 teaspoons of vanilla. Here's a diagram that shows the amount of flour and vanilla needed to make 1 batch of cookies. Draw a diagram that shows the amount of flour and vanilla needed for 2 batches of cookies. Write the original ratio of flour to vanilla and the new ratio of 2 batches. Take 60 seconds to draw your diagram and write your ratios. Here's the completed diagram. I'll step away for a moment. Check your work against mine. And what you'll see is that our original ratio of cups of flour to teaspoons of vanilla, which was in this diagram, was 5:2. And now when we consider both diagrams, if I add it up, I can see that the new ratio is 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. So my new ratio, when I doubled my recipe, became 10:4. Looking at each ingredient in the ratio, how did the amount of ingredients change when we doubled our recipe? Let's come back together. You may have noticed that each ingredient in the recipe increased. In fact, when I look at each ingredient, they were changed by the same factor. So when I look at the 5 cups of flour, 5 cups of flour became 10 cups of flour because it was multiplied by or scaled using a factor of 2 or multiplying by 2. The same thing is true for what happened with the vanilla. We took 2, we multiplied it by a factor of 2. 2 times 2 gave us 4. So what we just did here is we created equivalent ratios. In order to create equivalent ratios, you have to make sure that you multiply every single ingredient in the recipe by the same factor. That's the only way that we're going to ensure that we maintain the same taste. Remember my drink example? We'll continue to add to our understanding of equivalent ratios by considering yet another recipe. we're going to consider the ratios of ingredients in my recipe and how to adjust them to make different size batches. So here we have the ingredients in order to make my delicious tuna casserole. Go ahead and take 30 seconds to jot those down. Okay, let's first consider what is the ratio of ounces of soup to cups of cheese to cups of shredded pasta. Now remember, we can actually make a 3-part ratio because a ratio is a comparison of 2 or more quantities. Go ahead and write that down. You have 10 seconds. All right, I see that we have 10 ounces of soup and 1 cup of cheese and 3 cups of pasta. So now I'm gonna give you 30 seconds to create a diagram to represent that ratio. Here's the completed diagram. Check your work against mine. Now, I don't know how many people are gonna show up for my party yet, so I wanna have a recipe ready for a lot of people and a recipe ready in case I know a lot of people aren't gonna show up. So, considering these 3 ingredients, how much would I need to make 2 times as much casserole? And then I wanna make a separate recipe for how much would I need if I only made half a batch? Draw a diagram and write new ratios that represent 2 times the amount of casserole and 1/2 times the amount of casserole. Here's the completed diagram for 2 times the batch of casserole. You'll see that I have my original ratio of 10 to 1 to 3, and what I did was I doubled every ingredient, and my new ratio would be 20 to 2 to 6, representing double the amount of every ingredient. Now, what did it look like to take half of one of these? So I'm gonna go to this batch, which I know is 1. I'm actually gonna cut it in half. So the completed diagram for this one should look like half of 10, which is 5, half of 1, which is a half, and half of 3. I cut everything down the middle. Half of 3 is 1.5. So for half a batch of tuna casserole, my new ratio would be 5 to 1/2 to 1 1/2. In each of these batches, or each of these recipes, what I did was I multiplied the ingredients by the same factor. So for example, again, my original ratio was 10 to 1 to 3. And in order to make double the recipe, what I did was I multiplied each number by 2. 10 times 2 gave me 20. 1 times 2 gave me 2. And 3 times 2 gave me 6, representing double my recipe. Now, I did the same thing for the other recipe, except this time I multiplied by 1/2. So, I again started with 10 to 1 to 3 is my ratio. And I multiplied 10 times 1/2, and I got 5. 1 times a half is 1/2. And 3 times a half is 1 1/2. Again, I multiplied each of these by the same factor. So when I scaled the recipes up, or if I scaled them down, I multiplied each ingredient, every ingredient, by the same factor. And that's how what we were able to do, by multiplying by the same factor, by each ingredient, we were able to make equivalent ratios. I can say that 10 to 1 to 3, and 20 to 2 to 6, and 1 or 5 to 1/2 to 1 1/2 are all equivalent ratios. Let's see if we can continue to create equivalent ratios by multiplying each quantity by the same factor. So looking back at our recipe, what is the ratio of cups of pasta to ounces of tuna in one batch of casserole? For every 3 cups of pasta, we need 6 ounces of tuna. So our ratio is 3 to 6. Make sure you jot that down. We know that for one batch of casserole, we need 3 cups of pasta and 6 ounces of tuna. But what if I have 9 cups of pasta and 18 ounces of tuna? How many batches of casserole can I make? Take 60 seconds to find the number of batches I can make with 9 cups of pasta and 18 ounces of tuna. Remember, you can draw a diagram to show the ratio of cups of pasta to ounces of tuna to get started. Let's come back together. So I started by drawing my first diagram, which was 3 to 6, representing the original ratio of pasta to tuna. And then I took that batch and I tripled it. I multiplied it by 3. This is what my new diagram looked like. I now have 3, 6, 9 cups of pasta, and 6, 12, 18 ounces of tuna. And that's because I took this ratio of 3 to 6 and I multiplied each quantity by the same factor, which was 3. I know that three times 3 is 9. And 6 times 3 is 18. So that's my new ratio, which is equivalent to my original ratio. I know that 3 to 6 and my new ratio of 9 to 18 are equivalent because I multiplied each ingredient by the same factor. In every recipe that we considered today, the cookies and the tuna casserole, we scaled up our ingredients and we scaled down our ingredients by multiplying by the same factor. And that made sure that when we did that, we end up with equivalent ratios. So now what we're gonna do is do some more work multiplying by the same factor in order to create equivalent ratios. So let's consider 5 to 3 and 10 to 6. Here's the ratio of 5 to 3. And here's the ratio of 10 to 6. Now, I know that both of these ratios are equivalent, and that's because I can scale them or I can multiply by the same number to get the second number. So for example, if I take 5, I know that 5 times 2 gives me 10. And if I take 3, I know that 3 times 2 gives me 6. So because I multiplied this ratio by the same factor, which was 2, and ended up with 10 to 6, that means that these two ratios must be equivalent. Let's consider two other ratios and see if they're equivalent to the ratios that I have. So what about 15 to 12? Is 15 to 12 equivalent to my two ratios? What about 30 to 18? Okay, so I asked you to consider if 15 to 12 and if 30 to 18 was equivalent to 5 to 3 and 10 to 6, the ratios that I started with. So I'm actually going to start with 30 to 18 this time. So using the same method that I did before, I'm going to ask myself, is there anything I can multiply by? And it has to be the same number. Is there a number that I can multiply by 5 and a number that I can multiply by 3 that would give me 30 and 18? Well, I know that 5 times 6 gives me 30. And actually, I know that 3 times 6 gives me 18. So because this factor of 6 is the same, that means what I've done is created an equivalent ratio. 30 to 18 is an equivalent ratio to 5 to 3 and to 10 to 6. Now let's go to my other example, which was 15 to 12. When I think about what can I multiply 5 by to give me 15, I know that 5 times 3 gives me 15. But then, if I wanted to make 12 using multiplication, I actually would have to multiply 3 times 4. So, because these factors are not the same, I would say that this ratio of 15 to 12 is not equivalent to 5 to 3, because the factor that I would need in order to multiply to create the other ratio is not the same. So now that we know that in order to create an equivalent ratio, we have to multiply each number by the same factor, as we did here and as we did here. I want you to take the next 30 seconds to come up with as many equivalent ratios to 5 to 3 and 10 to 6 as you possibly can. Here in blue, I have a few of the different equivalent ratios that I came up with. You may have some different ones on your paper, and that's fine. What's really important here is that the way that I created these equivalent ratios was by multiplying each number in the ratio by the same factor. If you multiplied each number in your ratio by the same factor, you can ensure that you were able to create equivalent ratios. We started our work together today by thinking about scaling up or down recipes. We worked with my drink mix at the beginning, we worked with some cookies, and then we worked with my dinner favorite, which is tuna casserole. And the important thing to remember is that we want to have the same taste in our recipes whenever we scale up or down. We wouldn't want the taste to change because we change the ingredients. So the way that we make sure that we scale up and down and maintain the taste is that we multiply each of the ingredients by the same factor. Equivalent ratios are created when we multiply each number in the ratio by the same non-zero number. Based on our work today, here's a problem to consider before our next class.
Practice aligned to the learning from today's episode can be found here.